Okay, no problem. Today, no, you can stay. Yes, am I right? You can stay right now. In the morning, we did not. In the morning, we did not have new lessons. Just we review the sections before. Okay. As I told you, there are some factors that can affect the structure and the stability of macromolecules. For some experiments, the natural structure of macromolecules should maintain, okay? Should maintain, and we need the natural structure. But sometimes, no, we don't need the natural structure, and it's not important that it holds or not. There are three factors that can affecting the analytic structure and its stability. What are these three? Let me tell you. These three ones are pH, temperature, and solvent polarity. So when we want to work with some macromolecules and we want to do experiments on these macromolecules, we should be aware of these three factors. I mean pH, temperature, and solvent polarity, and they are very important for my exam too. In practice, most of the biophysical procedures means some ways or some methods that we use in working with macromolecules. Most of the physical procedures described here use conditions which have been optimized over very years for thousands of different samples. Each sample has its special optimized temperature, pH, and solvent polarity. For example, there are some enzymes that work in pH equal to 3, and some enzymes are stable in pH equal to 7, for example. So we should know it. We should know the optimized condition of the macromolecule that we want to work with. Clear? Is it clear? So we should be aware of the optimal condition of the macromolecule that we want to work with. I think some of the students have a problem with internet, huh? You are in Iraq or in Iran? In Iraq. I don't know, maybe some parts of Iraq maybe have problem with internet, but the others of yours, I think Wi-Fi, the internet of home. Wi-Fi is better than the mobile internet. In Iran, it's true. It's true in Iran. Wi-Fi, the internet of our home, is really better than internet of my cell phone. So please use Wi-Fi. Wi-Fi is better because mobile internet is not very good. Sometimes I work with it. It really annoys me. Okay, some procedures like chromatography, capillary electrophoresis, or crystallization may require case-by-case optimization of condition. What do we mean by case-by-case optimization of condition? What do I mean by it? When I say case-by-case optimization of condition, I mean the condition for each sample is different. For example, I have 3 enzymes, enzyme 1, enzyme 2, and enzyme 3. The condition of enzyme 1 is different difference with the work condition of enzyme 3. For example, enzyme 1 needs the temperature of 37 centigrades, but the others need 35 centigrades. Or for pH, for example, one of the enzyme needs pH equal to 3, one of them needs pH equal to 4. They are different, okay? So we should optimize the condition for each of our samples separately, okay? And we should study about the sample. For example, I should have enough knowledge about DNA. What is the optimal condition for working with DNA, or what is the optimal condition of working with protein B, for example? So, however, the most important factors that can affect analysis structure and stability are pH, temperature, and solvent polarity. Next slide. This knowledge, I told you, we should have knowledge about the experiments and of course the macromolecules and their optimized condition. This knowledge can help us to design a suitable solvent or set of chemical conditions which can maximize the stability of the analysis for the duration of the experiments and may also help us to explain unexpected results. Okay? Moreover, many of techniques described in this volume or this chapter in this section are actually designed to suboptimal and to take advantage to this disruption of the normal function, structural and biomolecule to facilitate the separation of analysis. As you know, for some techniques, such as HPLC or electrophoresis, we don't want the natural structure of macromolecules. When we don't want the natural structure of macromolecules, and it's not important that they are the nature or they are not in the nature, do we need optimal condition or not? Imagine, listen to me, imagine we want to do an experiment that the structure of protein after the experiments is not important to us. Like electrophoresis, HPLC, the structure and naturality of the protein or of the macromolecule of DNA is not important to us. So is it necessary to optimize the condition or not? Is it necessary to optimize the condition or not? Do you understand what I mean? Do you understand my question? No? You know, we have I want to do an experiment. I am repeating. Imagine we want to do an experiment, okay, like electrophoresis or HPLC. Imagine I want to do electrophoresis or HPLC, okay? But in this experiment, it's not important to me that my for example, protein be natural or unnatural. It's not important to me. Does it separate from each other or not? So the structure of my protein is not important to me. Just I want to do my experiments. If the protein be degrade is not important to me. Okay? So in this situation, is it necessary for us to have optimum or optical condition or not. When the structure of protein is not important to me, when the degradation of the protein is not important to you, is it necessary to have optimum? Yes. I think Mr. Muhammad Yahya understand what I mean. How about the others? Do you understand me or not? It's not important. When the structure is not important to you, so there is not any need for you to optimize the condition. Clear? Okay. Now, another imagination. Imagine you want to experiment that you don't want your molecules like protein to be heated. You don't want them to be changed. You need unchanged. You need them to be unchanged. You need their structure. You need their stability. You need to be natural in all the stages of experiments. Okay? So, what should you do when you need this structure? Anything in this way, what you? Yes, you need this condition. And now I want to tell you how to optimize the conditions. How to optimize the conditions. Yes. As I told you, there are three factors that can affect the structure and the stability of macromolecules. One of them is pH effect. What is pH? pH is defined, I'm talking about here. pH is defined as negative logarithm of proton concentration. It is about the proton concentration, the negative logarithm of proton concentration. So pH is equal to minus logarithm of H plus. Because of both H plus and pure water are 10 equal to minus 7 molar, this scale returns for maximum of 14 to minimum of 0. So the pH starts amount of 14. And which range is considered as acidic, or which of them is basic? Would you please tell me? What is the range of acidic? Acidic is, yes, 0 to 6. Below 0 is acidic, it's basic. Alkaline, sometimes we say alkaline or basic. Basic or alkaline. Alkaline means basic. Alkaline or acid catalyzed hydrolyses are extremes of pH scale but are generally stable in range to 3 to 10. So, usually the biomicromolecules, this is very important, this part is very important. Biomicromolecules are usually stable pH. It is usually analyzed such biopolymer of pH value where they are structurally stable, and this may differ slightly for individual biopolymer. For express in lysosome are stable in pH 4. But the proteins that are in cytosol are stable in pH 7. So for example, imagine I want to work with protein is the optimal pH. Please remember it. Please remember it. It may be one of your examples to work with a protein that is from cytosol. Okay. What is the optimum pH for this? 7. Yes. How about the protein from lysosome? The optimum pH for it is 4 because lysosome, the environment of lysosome is acidic. The environment of lysosome is acidic. Okay, before continue, I want to ask you something. I want to ask you something for me. Okay? As I am saying, Mr. Muhammad, Yahya, Mr. Murtaza, Ahmad Jawad, Miss Elham, Mr. Wurud Nazem, and some of these students can understand what I said, and maybe it's because Mr. Forrest, of course, and it's because they know English, and some of you you know Farsi too. But unfortunately, I think some of these students send messages to me that they don't understand English and they don't understand Farsi too. And when one student don't understand Farsi or English, I don't know what to do for him or her. Would you please help ask the students if there is some students in the class that they don't understand English, and of course they don't understand Farsi too, and just they understand Arabic. Please help them in the lessons because I'm really concerned about them. Would you please help them and teach them the things that I'm telling you? Would you please help them? Because I'm concerned for that students that are English, and I cannot do anything because I cannot speak in Arabic. Thank you. So please help them because please help them. I want all of you to understand the lessons. However, excuse me because I cannot speak in Arabic. I don't understand Arabic and what will happen. Okay, temperature effect. I talked about pH effects, but now I want to talk about temperature effects. You know, temperature by itself can affect 3 things in a biomolecule. Temperature by itself can affect 3 things of a biomolecule: structure, chemical reactivity, and solubility. Structure, chemical reactivity, and solubility. Okay? Can change the chemical reactivity of a microstructure, can also change the solubility of a macromolecule. So imagine in the exam, I ask you, what can temperature do? What are the effects of temperature on the macromolecule? You should say the temperature can affect on structure, chemical reactivity, and solubility. Clear? No. These are effects. Heat, garma. Okay, heat, can disrupt non-covalent bonds such as hydrogen bonds, which are especially important in the structure of macromolecules. Yes, temperature increase solubility. Yes, Miss Allah. Make it here. Imagine I ask you a question that heat can affect them. Heat can affect non-covalent bonds. Heat can affect non-covalent bonds such as like hydrogen bonds. Okay, so heat can affect just non-covalent bonds. Imagine, don't please remember and don't forget that heat cannot affect covalent bonds. Just it can affect non-covalent bonds. Okay? Heat can affect non-covalent bonds. بله، حرارت میتونه تأثیر بذاره روی does not have any effect on covalent bonds because they are very stable. Is it clear? Clear? Is this sentence clear? Okay. This can lead to denaturation of protein and DNA. The heat can lead to denaturation. Again, okay, I told you heat, حرارت, okay, Mr. Morteza. Heat can can affect non-covalent bonds, just non-covalent bonds. But it does not have any effect on covalent bonds because covalent bonds are very stable. Heat just have effect on non-covalent bonds. Repeat again if you don't understand, no problem. Clear? Okay. So, this can lead to denaturation of protein when non-covalent bonds are broken. The protein or DNA will be denatured. Denature means not natural. Denature is opposite of nature. And we lose its natural structure. Moreover, since covalent bonds linking building blocks of molecules like peptide bonds, glycosidic bonds, or 3-phosphodiester bonds are very gently building blocks extensively in حرارت شدید. حرارت خیلی شدید. فکر کنم همین رو میگید. حرارت شدید can result in disintegration of covalent structure too. When we have mild حرارت ملایم داریم, when we have mild heat, it can just affect non-covalent bonds. But when we have extensive heating, very hot, شدید, حرارت شدید. When we have extensive heating, it can affect covalent bonds. So let me write it. Heat is equal to Greek covalent and extensive heat breakdown of covalent and non-covalent bonds, but mild heat is equal to down of just covalent bonds. Please write it down. Please write it. Extensive might hit just covalent bonds. Understand? Okay.
مو لازم ماما تروح على علي تجيبها من يطلع من الامتحان وبعدين تروح على محمد. وين
بابا حبيبي صندوق طلقات يا بابا يا بابا هذا أو شيء كبير أو شيء ضعيف.
The constants A, EA means activation energy, R is the universal gas constant, and T is the absolute temperature. This relationship arises from large chain of activated molecules available for reaction as a result of change in temperature. So when we say changing in temperature can change it's by this formula. By this formula, okay, Ka is the rate of reaction. سرعت. What do you say to rate in Arabic? What do you say to rate in Arabic? سرعت. سرعة. Yes, سرعت. We say سرعت. By increasing, if you look at this formula, by increasing T, the small, look at here, the small changes in T can result in the large effects on the rate constant or K. تغییر خیلی کم در دما سرعت واکنش یا کار رو به شدت افزایش میده. Is it clear? What does temperature means in Arabic? What does temperature means in Arabic? دما. حرارت. Yes, حرارت. Small changes, تغییرات کوچک. Small changes in T can have really big changes in K, سرعت. Small changes in T can have a big effect on K. Clear? So, the temperature can change the chemical reactivity. The سرعت or the نه تناسب معکوس نیست. For example, we have here the temperature is the سرعت, the rate is 6. Is it clear? Do you understand? التغير الصغير في السرعة التغير الصغير في السرعة يؤثر no Mr. Mohsen. التغير الصغير في حرارة okay تغير الصغير في حرارة كان تغير السرعة خیلی بزرگ و کثیر. تغییر صغیر فی حرارت کن تغییر سرعت کثیرت. I don't know how to say. Clear? Please read here. Read this. Yes, I know, Mr. Vurut. Change in temperature affects on car, but small changes in temperature can have a very big effect on car. For example, imagine in 5 centigrade, the car is 300, but after just a small, very small changes in temperature, change the cost too much. Here, the exponential dependence, it's exponential. چگونه میتوان از تناسبات why Mr. هیدر چرا باید از تناسبات خارج شد؟ چرا خارج بشیم؟ تغییر قلیل فی حرارت can یؤثر علی سرعت کثیرت. آقای فارس دوستتون میپرسن چطور میشه از تناسبات خارج شد؟ چرا باید از تناسبات خارج شد؟ I think it speaks too much. Mr. Haydar, I don't understand what you mean. Mr. Haydar, I don't understand what you mean. Excuse me. Mr. Forrest, do you understand what does he mean? This sentence is very important. Exponential dependence of نمیدونید منظورش چیه. من هم متوجه نشدم متاسفانه. The exponential dependence on temperature means that small changes in T عربی متسارع exponential effects means متسارع. Exponential effects mean متسارع. Exponential. This is the متسارع effect. The effect that is متسارع exponential. I understand. How were this ratio between R and T calculated? You know, all the formula, Mr. Haydar, all the formula has some stages, and there were some scientists that understand them. These have some stages, but I miss a spot formula. You understand? اثبات فرمول رو میخواید؟ اگر دوست داشتید اثباتش رو براتون میفرستم. It has some stages until they achieve to this formula. If you want to know the stages, I will tell you next section. Okay? It has some stages, Mr. Haydar. Effect of temperature usually increase the solubility of the molecule of the solvent. متسارع. I told متسارع. This is because that heat increase the average kinetic of energy of solvent molecule. As you know, when we have heat, the kinetic or the movement of the molecules will be more, and so they can be solved in the solvents more and better. In the case of water, this is accomplished by extended breakdown of water-hydrogen bonds, which increase the solute capacity of the given volume of water. For example, 8 molar urea is soluble at 30 centigrade, while the limit solubility is closer to 5 molar at 4. What does it mean? It says that in high temperature, we can solve more urea in water. Here, in 30 temperature, we can use 2 molar urea, but in 4 temperature or in 4 centigrade, we can add some 5 molar urea in water. Energy effects are also important in situations involving biological membranes because phospholipids bilayers of which they are composed become increasingly fluid at higher temperature. So at higher temperature, the phospholipid bilayer of our cells will be more fluid. Temperature is therefore usually tightly controlled during the physiological and biophysical experiments. Okay, two factors that can affect the structure and the stability of molecules. One of them was pH, and the others were temperature. And I told you that temperature can affect 3 factors. What was the factors that temperature could affect them? Structure by affecting the and as I told you, as much as the highest in high temperature, the solubility will more and more. Is it clear until here? Until here, is it clear? The other effect is about the solvent polarity. The solvent polarity. But before talking about solvent polarity, do you agree to have a break time? Do you agree to have a break time, about 10 minutes or more? Do you agree to have a break time? Okay, now it's 1:55 p.m. We have a break until 2:10 p.m. 2:10. Until 2:10, you can have in the I think time is 10. Yes, 15 minutes. Thank you. Come back in 15 minutes.
تعرف بالحسنة شوف تعرف بالحسنة
صعب تقطع صعب من شعبتي من نفس شعبتي مصابين كلش تعبان